Good afternoon everyone. My subject is operating system. Today I am going to discuss about CPU scheduling algorithms. First of all, I would like to discuss about what do you mean by scheduling algorithm. Scheduling algorithm is a mechanism which is used to schedule a process to a processor. Process means it is nothing but a program under execution. Next, processor means nothing but a CPU. So we are going to schedule a process to a processor for execution. In that we are in scheduling algorithms. Okay. So scheduling algorithms are divided into two categories. One is the preemptive scheduling algorithm. Another one is non-preemptive scheduling algorithm. So what do you mean by preemptive and what do you mean by non-preemptive? Preemptive means if a process is currently running by the CPU and if a process P1 is currently under execution and process P2 has arrived, next the CPU will preempt the currently running process, that is P1, and it will take the P2 process for execution. Why? Because P2 process is having more priority when compared with the P1 process. That's why it will preempt the currently running process only when the next process is having more priority when compared with the currently running process. That is nothing but the preemptive scheduling algorithm. Next, coming to next one, that is non-preemptive scheduling algorithm. Non-preemptive scheduling algorithm will not leave the process until unless the process completes the execution. That is nothing but a non-preemptive scheduling algorithm. And examples of preemptive is SAF. Next, priority, round robin. Next, coming to this non-preemptive, FCFS, SAF and priority. So first, I will discuss about what do you mean by FCFS. FCFS stands for first come first serve. It falls under non-preemptive scheduling algorithm. So first come first serve means what? Whatever the process which is arrived to the CPU first will get executed first. That is nothing but the first come first serve. And SAF stands for shortest job first. So this scheduling algorithm will depends on the lowest burst time. So it comes under both preemptive and non-preemptive as well. Next, priority. Priority in the name itself is telling if the process is having more priority, then CPU will take the process, that process only for execution. So this also will comes under non-preemptive as well as the preemptive. Next, coming to the next one, which is under the preemptive, round robin. Round robin will depends on the time quantum. Time quantum is also called as the time slice. So for execution, so we will be getting the time quantum in the problem. Based on the time quantum, the process will execute. So it will be going in the further rounds. That's why it is called as a round robin. Next, I will explain problem related to the FCFS. So before coming to this FCFS problem, I would like to discuss about some terms which is used in solving the scheduling algorithms. So first term is arrival time, AT. AT will be there. Next, BT will be there. CT will be there. TAG will be there. Okay. So AT stands for arrival time. Arrival time is what? The process which is arriving first to the CPU. So that process only will get executed. That is nothing but the arrival time. Okay. Next, burst time. The time taken by a process for execution. That is nothing but the burst time, BT. Next one is CT. CT stands for completion time. So completion time is what? The time taken by a process to complete its execution. That is nothing but the CT. TAG. TAG stands for turnaround time. So we are having some formula for TAG. So TAG is nothing but BT minus WT. So what do you mean by BT and what is meant by WT? BT I have already discussed, that is nothing but the burst time. And next one is WT. WT stands for the waiting time. So how long a process is waiting in a ready queue for getting executed? That is nothing but waiting time. So I will solve the problem now. having the serial numbers for the process P1, P2. So I am taking 4 processes which is having arrival time of 0 for P1, 2 for P2, next 3 for 4 for P3, next one is 6, next one is 8. So this is the arrival time for these 5 processes. Next, coming to the burst time. So like this we have to arrange the problem in the tabular format. So these 3 columns will be present in the problem as well. Next we have to calculate this one. So for calculating this one, first we have to draw the Gantt chart. So every process will arrive at a 0 arrival time. So at 0 arrival time, the first process has arrived already in the CPU, that is the P1 process. So at 0 unit of time or 0 arrival time, P1 has already entered into ready queue. So what is the burst time of P1 is 3. Next, what is the next process which is in ready queue? That is the P2 process. So we have to add the burst time for the previous process. So 3 plus 6. 3 plus 6 is equal to 9. Next one is P3 process. So 9 plus 4, that is equals to 13. Next P4 process. 13 plus 5, that is 18. Last one is the P5 process. So P5 process is having a burst time of 2. 18 plus 2, 20. Okay. So this is how we are going to calculate the Gantt chart. Based on the Gantt chart, we are going to solve these 3 column values. Okay. So whether our problem is correct or not, we can check it by doing the summation of burst time. 3 plus 6 equal to 9, 9 plus 4 equal to 13, 13 plus 5 equals to 18, 18 plus 2 equals to 20. So what is the last value of the Gantt chart? That is 20. So our problem is correct. Okay. So we are doing it correctly. Next, so completion time. Completion time is the right hand side values of the Gantt chart. So P1 right hand side is what? 3. So we have to write it as 3. Next P2 right hand side, what is the value of right hand side? For P2 that is 9. Next P3 is 13. P4 is 18. P5 is 20. So completion time values will be taken from the Gantt chart from the right hand side. Okay, for each process. Next, we have to calculate the TAT and WT. So TAT is having a formula that is equals to CT minus AT. WT equals to TAT minus VT. So TAT equals to CT. CT means what? Completion time. AT means what? Arrival time. So CT minus AT will give you the TAT column value. So we have to solve this one for each process. 3 minus 0 equal to 3. 9 minus 2 equal to 7. 13 minus 4 equals to 9. 18 minus 6 equals to 12. 20 minus 8 equals to 12. Next, WT. What is the formula of WT? TAT minus VT. So TAT we already got. TAT minus VT. So this minus this. 3 minus 3 equals to 0. 7 minus 6 equals to 1. 9 minus 4 equals to 5. 12 minus 5 equals to 7. 12 minus 2 equals to 10. Next, finally, in the problem they will be asking you to calculate the average of TAT and average of WT, that is waiting time. Only these 2 terms we have to calculate. Okay, in the problem. So we have to calculate first the TAT column. So the summation of TAT and the summation of WT we have to calculate. So 7 plus 3 9. So 7 plus 3 10, 19, 21, 23, 43. Next this one 17, 18, 19, 20, 21, 22, 23. So this is the values for TAT and WT. So TAT value how much we got? That is 43. WT value we got as 23. So we have to do the average of TAT. Average of TAT equals to 43 by 43 by 5 will give you the average stat value. Next, similarly, we have to calculate the average waiting time also, that is 23 by 5. So this is how we are going to solve the scheduling algorithms. So first come first serve, it is very simple algorithm. So it depends on the arrival time. So what are the process arriving first in the ready queue, that will get executed first. That is nothing but the FCFS. Okay. Thank you.